Astronomers believe that nearly every galaxy has a supermassive black hole at its centre, something that is true of our very own Milky Way. These objects exert such strong gravitational forces on the matter contained within them that it cannot escape a black hole's pull. Scientists using the LOFAR telescope in the Netherlands have been studying the impact that such black holes have on the universe. But at a big, and I mean really mind-bogglingly big, scale. One of the scientists working on the project, Marisa Brienza from the University of Bologna, told Cameron Voice what they found.
We have observed for the first time the impact that a supermassive black hole sitting at the center of a galaxy has on the surrounding medium on very large scales, up to hundreds of light years. We have seen in other systems multiple generations of bubbles of particles produced by the black hole. But the main difference this time is that the system was quite close by and quite large. And we observed it with this very powerful and new generation instrument at low frequency. So we could really observe the details of how these bubbles evolve in time on very long time scales, and how the gas of these bubbles gets distributed in the space, creating all these very stunning details, like these rings and filaments.
What does it mean for there to be a bubble?
When I speak of a bubble, I mean that the black hole is able to accelerate particles, so the gas around it, up to very high speeds. And so this gas becomes highly energetic and is pushed away from the black hole, creating these streams, which we call jets. And these jets then create these bubbles of particles, which are like clouds, for example, in our sky, pretty similar. And these bubbles can then, or clouds can then expand in the surrounding medium and interact with the surrounding gas, exactly like a cloud in our sky.
Yeah, so you mentioned these structures, these rings, these filaments. How should I be picturing these things? What should I be imagining? How big are they?
So they're actually pretty big. Yeah, there are hundreds of million light years. So very, very much bigger than the host galaxy where the black hole is sitting.
And what are the implications of your study for how we understand galaxies and the universe more widely?
We want to understand the impact that black holes have on the galaxy evolution and also on the medium surrounding the galaxy. And this means understanding how galaxies, for example, form stars, how they collide with each other, and how they change. Understanding the impact, the energetic impact that the black hole has on the surrounding environment, not only on the galaxy, but even much further, is really important for this, because all this energy that the black hole is releasing is really influencing the way the galaxy forms stars, for example. Stars are formed from cold gas, which starts collapsing under gravity, under the influence of gravity. But of course, if this gas gets heated up, for example, by the energy released by a black hole, this gas will stop condensing and stop forming stars. So it means that the galaxy overall will going to switch off, let's say, to stop creating new stars. And this is really important to understand how it happens, also to understand how it happens in a different way in different moments of the universe evolution, to understand how we got to the universe as we see it now.